These data are from a set of measurements from films of polyvinyl ethyl ether on polystyrene. And what we're going to do is use one of these measurements to illustrate how to do quantification using tags, where a quantification based on the survey spectrum is further analyzed using the data from a high-resolution C1S spectrum, which represents the proportions of polystyrene to polyvinyl ethyl ether. So we'll begin by loading an element library so that we can quantify the oxygen against the carbon based on the survey spectrum, and we're using a Schofield library to do this. That's to say that we don't have any escape depth correction because we're looking at a thin film of polyvinyl ethyl ether on top of the polystyrene, and we're interested in the oxygen and the carbon ratio from the polyvinyl ethyl ether. So, having obtained a quantification from the survey spectrum in terms of oxygen and carbon, we're now going to look at the C1S, and we're going to use measurements from standard polystyrene and polyvinyl ethyl ether, where we've got C1S peat shapes, and these will be used to construct line shapes from data. So we're adding a region with a background, and then we're going to background subtract these data using the processing option on the test data tab, and then we're going to copy the process data and create two new VAMAS blocks that will represent line shapes from data for each of these different materials. So we're going to give them the names, that's the VAMAS block names, with the prefix %, less than, greater than, and that indicates that we've got a line shape and we want to process it in a certain way, whether it's being processed from data. And then we'll just verify that these line shapes have been calculated correctly by fitting them back to the data, which also has the effect of adding a line shape to the list of available line shapes. Once used, the line shape becomes part of the system available line shapes. So we do two functions here. That is, we check that the data is consistent with the line shape, and we also make the line shapes available for analysis elsewhere. So we'll go back to the carbon 1s and from the unknown sample, and we're now going to create a peat model using two components, where the two components represent polystyrene and then polyvinyl ethyl ether. And again, we can select these from the list that's obtained by control and click before it's an edit field. So we get two line shapes, and we can fit these to the data. And then using quantification using tags, we want to set no tag for the region on the high resolution data and make sure that we have the appropriate tags, C1S for the components and C1S on the survey, and also O1S on the other region, so that when we select the survey and the C1S and we use a particular type of annotation table using the quantification and using tags, we can then select the survey and the carbon 1s and therefore see the proportion of the C1S from the survey as calculated from the high resolution. And just doing a little bit of refitting of the C1S, we end up with a proportion of about 4:1, which is polyvinyl ethyl ether.